It's been so long that I was looking to come up with a so I recorded the shortest one. I recorded the shortest one that nobody liked.
Okay, this is the table of contents, so add in pages 16 and 17 for today. Okay, so let's look at our notes for today. So this is using the same data that we looked at on block day with the number of people in a household in the United States. So we're still using the same information, but now we're going to be looking at some other measures, mean, standard deviation, those type of things. So typically when you think about finding a mean, this is what you do. You add up all the numbers, so we add up all these numbers of persons, and then we divide by how many numbers we have, and we get the mean. But it doesn't make sense to do that here. Any ideas? So it doesn't make sense, but why not? Why can't we do that?
Because all the categories aren't the same.
Ooh, perfectly said. Did you guys hear him? Because all of these different outcomes are not they're not the same likelihood. They're not the same probability. So some of these occur more often than some of these other ones. So it's just the same as whenever I'm doing the grades in this class. When you're looking at your grades for quizzes, for tests, for homework, for the final exam, those are weighted differently. I don't just take all of the groups and average them. I weight this. This is the same idea here. It's like finding a weighted average. Okay? Way back in the day, back when I was in school, we all knew how to do this because we didn't have Roger Hub. We didn't have all these things to tell us what we need on the final. So we knew how to calculate these. You guys probably don't do this as often, but it's something you'll need to be able to do here. So does it make sense? No. Because each outcome is not equally likely. All the probabilities were equal, we could do this and get the average. That would be accurate. But when they are not, we have to do a weighted average. So this is our formula for getting that. It looks really complicated, but it's not that bad. Basically what it's saying is this symbol just means sum. So we're finding the sum. We're adding a bunch of things together. And this is what we're adding together. Each possible value times its probability. Okay? So what that looks like when we write it out, our first possible outcome is 1 with a probability of 0.25. So to write this out, E of x, or mu for the mean, is equal to 1 times 0.25. There's that first value times its probability. And we add to that the next value times its probability. So 2 times 0.32. And we just keep going until we have all the outcomes multiplied with their probability. Then you should be able to just type all of that into your calculator and get the expected value. So that's what E of x, this is the expected value of x, which is also the mean, which comes out to 2.6. So when you encounter a question that's asking you to do this, sometimes they will say find the expected value, sometimes it'll say find the mean. Both of those are the same operation. So this is the expected value, this is the mean. So if you need to make a note to yourself, both of those mean the same thing. So as we've done before, every time we calculate a value, we need to be able to explain what does this mean. So here we want to explain what does this number 2.6 mean in context of this situation. So I'm going to show you two different ways because on a multiple choice, sometimes they'll say which is the correct interpretation, and it could be either one of these. So I want to make sure that you see both ways. So on average, we expect each U.S. household to have 2.6%. Or, other way they could write it is if many households are selected. The average household size will be 2.6 people. So you may see on the multiple choice, you may see it written this first way, or you may see it the other way. They will not have both options available, but it may be they have either one of those. So the big idea is we're looking at, on average, for a lot of people. If you do lots and lots of households in your sample, this is what we expect to get. Questions so far? Are we good with this process of finding the mean and interpreting? Look at the back side. So here we're going to introduce the word variance. We haven't talked about variance before, but we've talked about standard deviation as a measure of spread. Variance is just another measure of spread. It's related to standard deviation in that if you take the square root of the variance, you get standard deviation. If you know the standard deviation, you can square it and get the variance. So they're both measures of spread. It's just kind of in different units. So they're related to each other. When you do the probability models and you're finding the spread, you have to find variance first and then take the square root to get standard deviation. Okay, because our formula is for the variance. So this is our formula. So we're used to saying sigma for standard deviation, so sigma squared is variance. So here this formula is telling us take each of the values that we could get for our variable, subtract the mean, which we already calculated on the front was 2.6. So for each value, subtract that 2.6, square the difference, and multiply by the probability. Okay, and we just add them all together. So it sounds complicated, but it's not like that. It looks so easy. It's not at all, I promise. So sigma squared. So this is, you're going to get to learn your Greek alphabet. This is lowercase sigma, this is uppercase sigma. So both Greek letters. There you go. You'll get to know all your Greek letters next year, I'm sure. So, the way we're going to do this, you'll notice the first value is 1 with a probability of 0.25. So back here, we're going to take that first value of 1 minus the mean, which was 2.6, square it, and multiply by the probability, 0.25. Do that with the second term, 2 minus 2.6 squared times its probability, which was 0.32. We'll just continue that for each of the different values and their probability. good news is, if I give you one of these on a quiz or a test or on the AP test, when you see it, you're not going to have 7 different possible outcomes. Most of the time, 3 or 4, maybe 5, but there won't be that many that you have to write out. It'll be shorter. So then you're just typing all that into your calculator, making sure to watch your parentheses and all of that, and we get 2.02. Exactly.
So that's the only one.
Right. Okay, so that gives us variance to get standard deviation, which is usually what we talk about to describe spread. We just take the standard deviation is sigma, like they were saying, which is just the square root of our sigma squared that we just found up above. So if we're wanting to find sigma, we just take the square root of sigma squared. So here we'll have the square root of 2.02. We have 1.4213. So, think back to standard deviation is measuring what? What are we measuring when we talk about standard deviation? Exactly. We want to know what is the average distance each value is away from the mean. That's what we're looking at. That's why in our formula, we're taking each value and subtracting it from the mean to get that distance and multiplying by the probability that we get that number. Okay? So, if you remember what standard deviation is measuring, it makes it easier to do the math part. Okay? You're finding the distance from the mean. So, to interpret this, we're going to use the idea of difference from the mean. So, first thing I usually put in is my context, just so it doesn't get left out. So, the number of persons in a U.S. household. Typically varies. Around the mean of 2.6%. By about 1.4213%. Yes, perfect. Either typically or on average or something to say this is a generalization. So some kind of phrase to show that. Yes?
Can we say something like that with variance, or we have to convert it to standard?
Well, the idea was interpret standard deviation. So you want to make sure you're matching up to what they ask you to interpret, but they could ask you for variance. Yeah. Anyone else? Questions on that part? Okay, so this is going to go on page 16 in your notebook. After you get that all attached, I want you to turn to page 4 in your notebook where your formula sheet is, and we're going to identify where these formulas are so you'll know where to find them on your formula sheet. second column, third and fourth ones down. Once you have this labeled on your formula sheet, then make sure your problem set is attached to page 17, and then you can work through